Today we can solve the problem by using CP rule. The very first problem, show that R conditional S can be derived from the premises P conditional Q conditional S, negation R, disjunction P and Q. So this is the problem. We are going to arrive the conclusion using these premises by using CP rule. So using CP rule, already we know that CP rule, what do you mean by CP rule? A formula S can be derived from another formula R and a set of premises, then the statement R conditional S can be derived from the set of premises alone. In other words, if the conclusion is of the form R conditional S, then take R as the additional premises and derived S using given premises and R. Okay, so this one will be the CP rule. So what we are going to do here, the conclusion, first I am going to write the premises one by one. H1 P conditional Q conditional S, H2 negation R that is disjunction P, H3 is Q. Using these premises, I am going to derive or I am going to conclude the conclusion as R conditional S by using CP rule. So already you know that CP rule means a formula S can be derived from another formula R and set of premises, then the statement R conditional S can be derived from the set of premises alone. In other words, the conclusion is in the form of conditional. So here the conclusion is conditional. Then take R as the additional premises and derive S using given premises and R. Okay. So this is the rule. We are going to use CP rule. Okay. So once again we have the same. Using CP rule, what we are going to do? First I am going to introduce the premises. So here first I am going to write the additional premises. Here the additional premises is R. So first I am going to introduce the premises R in the derivation. So I can write rule P. So within bracket you have to write additional premises. So why I am going to write additional premises? Using CP rule, if the conclusion is a conditional statement, then you can write R as additional premises and derive S from using the rules of inference and along with the premises, and finally you can write R conditional S and derive S, and finally you can write R conditional S, isn't it? Okay, second statement. So I am going to introduce another premises, negation R union, that is disjunction P. Second premises I am going to introduce. So I can write rule P. Okay. So third one, I can use equivalence involving conditional R conditional P. So I can write rule T. So equation 2, I can use equivalence involving conditional. Did you remember? P conditional Q is logically equivalent to negation P union Q. See the statement, negation R union P, so that is equivalent to P conditional Q, negation R, so R conditional P. Okay, and fourth one, I can here first statement is R, third statement is R conditional P. Therefore P, I can apply modus ponens. Using statement 1 and 3, I am going to apply modus ponens. Then I am going to introduce the premise P conditional Q conditional S. So here I can write P. So here using the statement 6, 4 and 5, P conditional Q, P, therefore Q, isn't it? Modus ponens, Q conditional S. So here I can write rule T using equation 4 and 5 by applying the rule modus ponens. Modus ponens, I can get Q conditional S. Now I am going to introduce the premises. See, the premises Q. So rule P. So fine. Once again, I am going to apply modus ponens. See, Q conditional is Q, therefore S. So yes, I can write rule T using equation 6 and 7. Once again, I am going to apply modus ponens. See, you have to check whether all the premises we can introduce in the derivation. See, so first premises is additional premises are, because I am going to apply CP rule. CP rule means if the conclusion is of the form R conditional S, then take R as the additional premises and derive S by using given premises and R, isn't it? So additional premises is R, and then I can apply second premises. Yes, first one. Second Q is also I can introduce. See, yes, P, this also I can introduce. You have to check whether all the premises you can introduce in the derivations. Yes, third is also I can introduce, and finally I reach S, and last statement you can write R conditional S. So this is T 1 and 8. I am going to use CP rule. If the conclusion is the conditional statement, then you can take R as the additional premises and derive S, and using given premises and R, finally you can write R conditional S. Rule T. So using equation 1 and 8, you can write CP rule. Okay. Suppose if the problem is not using CP rule, how we are going to derive the conclusion? Okay. Using premises, how we are going to derive the conclusions. So without using CP rule, how we are going to derive the conclusion? Okay, so once again here I have H1. What is your H1? First premises is P conditional, Q conditional, S. H2, negation R, union, that is disjunction P. H3, Q, and you can derive the conclusion as R conditional S. Here I am not using CP rule, so I don't want to take R as the additional premises, so you can directly prove the results. Okay, so first one you can write statement reason. Now I am going to introduce the premises negation R, disjunction P. So here I can write a rule P. Next I am going to introduce the first premises once again, Q, P conditional, Q conditional S. So once again I am going to write rule P, because I am going to introduce second premises in the second step. Third step, I am going to apply some equivalence involving conditional. Directly I will get Q conditional, P conditional, S. So here I am going to write T. Second statement rule T, equivalence involving conditional. So how you are going to derive P conditional, Q conditional, S is Q conditional, P conditional, S. See, P conditional, Q conditional, S. So from the second statement itself I can derive this result. So see the board, P conditional, Q conditional, S means here I am going to apply equivalence involving conditional. Did you remember P conditional Q is equivalent to, logically equivalent to negation P union Q. So same thing here I am going to apply negation P union Q conditional S, isn't it? So negation P union. So once again I am going to apply the same negation Q union S. So these are all logically equivalence. So logically equivalence. So here all the connectives are same, because I am going to apply disjunctive. So here I can apply commutative associative property. Negation P union negation Q union S. Okay, so here I am going to apply commutative property. Negation Q union negation P. What is commutative? A union B equal to B union A union S. So here I am going to apply once again associative negation Q negation P union S. So once again I am going to apply negation Q conditional Q P conditional S. For this I am going to apply equivalence involving conditional. So negation this is after this is you can write union only. Okay, so after this only you can write Q conditional P conditional S. So directly I can apply here. Okay, if you practice more, then you can write the answer. Okay, I can introduce two premises. So one more premises left over I can introduce here. I can write P. So fifth one will be Q conditional, P conditional is Q. Therefore P conditional S. So here I am going to apply modus ponens using equation 3 and 4. And sixth one will be for the first one. What is first equation? Negation R union P. So R conditional P. So I am going to apply rule T, equivalence involving conditional by using equation 1. And seventh one will be, see, R conditional P, P conditional S. So finally I can arrive R conditional S. So here I am going to apply hypothetical syllogism using equation 6 and 5. I am going to apply hypothetical syllogism, so I can derive the conclusion R conditional S. Likewise, we can use rules of inference and derive the conclusion.